Hi everyone, this is just another quick video showing off the progress I've made on my virtual texture renderer. Even though the frame rate counter up the top is saying about 30 to 40 frames a second, it does run at solid 60 frames a second. It's only the video capturing software that's affecting the frame rate. The big change this time is the lighting. I wrote a really simple a light mapper that uses the GPU to write out all this lighting data. It's really simple. How it works is to get like the shadows. I place the camera at the position of the pixel in the world, and then I point the camera at the light. Clear the color to white. Render everything black. Then take that render target, sort of then map that down through bouncing it between render targets down to a 1x1 render target. Then write that one render target into a 256 by 256 texture. Once all those pixels are done in that texture, then write out the TGA file. To do that for a 16 by 16K world, this took, let me look at my notes, 17 hours. So it's pretty slow. I spent no time optimizing it. I'm not convinced doing it on the GPU is the fastest way, because while my GPU is sitting on 99% utilization, my CPU's, like, I've got 8 cores in this thing, were practically idle. So I don't think it's the best use of resources, but it was really simple to write. It was probably like 100 lines of code, and I didn't have time to write a full ray tracer, although that would be fun. But I didn't just bake out shadows, I also did an ambient occlusion pass. So you can see under here you get, like, normally this would be all one flat color because it'd be all in shadow, but now at least we've got some variation. Similar idea, except for instead of when I move the camera to the pixel, I point it along the normal, and then set the field of view really wide, and then do the same thing, sort of mip down to one by one render target. It gives like a approximation of ambient occlusion, and I think it looks pretty good. But here's the rub again. This took 32 hours to compute on this PC. So again, probably should look at writing a ray tracer, or maybe using some R package to bake this out. But it was a fun experience, and it taught me that one of the biggest challenges of writing a system like this is actually going to be the art pipeline. The runtime stuff is actually quite easy. Well, not easy, but quite solvable. But the whole asset pipeline, that is the challenge. In fact, the only runtime things I changed since the last video was, now I use, if a texture is not currently available, I use a lower MIP version. So as I fly around, you'll probably see things start a bit blurry, then become a bit sharp. I don't know, the video quality might hide that a bit. To show it off too, I slowed down the loading of the images, so show it off. In fact, if I sort of occlude the whole world behind this pipe and then pop out, you should see things load in. Let me try that again. Actually, let's go inside the pipe, and we'll pop out. You can see everything sharpen up as it loads in. Yeah, this is pretty cool. It's very naive. In fact, one problem you can get. It's been hard to show. Yeah, so if I pull back from this poster, and then if we zoom in quite quickly, it can actually go blurry before it sharpens up. What's happening there is I'm throwing away, I'm naively throwing away pages that it thinks aren't used anymore. So I'm only tracking when that page table is currently not like found in the readback buffer, which is this thing here down the bottom. But I'm not checking to see whether any higher MIPS are using that. It should be a pretty easy fix. The other thing, I think the next thing that I want to fix is the bilinear filtering. You can see here I get this big seam down along here, but if I turn bilinear off, it's fine. I've talked about this before. This is just reading over like when the bilinear sampling crosses a border. I think, as I said before, just adding some borders or guards to these pages should fix that. Yeah, should start. I'd like to start looking at better caching schemes, like you saw, like when we occlude everything and then suddenly pop back around. It's thrown everything away. Definitely would like to play around some different algorithms for that. And I want to speed up the loading too. This is artificially slow at the moment, just to show off the sort of the loading in. But it's at the moment it's loading in uncompressed TGA, so there's definitely a lot of room to optimize that. I think that'll do it for this video. Thank you for watching. Also, if you want to see some of my light map stuff in progress, you can check my blog, Fragment Bound. I'll put a link to that in the video notes. Thanks for watching. Bye.